Hello, Algebra 1 students. We are moving on to multiplying polynomials. Now, in the past, this has been 2 different videos, so I'm going to try to cut down on the length a little bit, but I did have to combine it because of Snowmageddon 2015. So let's go ahead and start with a review of the distributive property. So you know the distributive property as the pass it out to the parts of the expression in the parentheses property. So what we're saying here is that we are multiplying 3 times the sum of x and 2. So that's 3 times x and 3 times 2. So 3x plus 3 times 2 is 6. So 3x plus 6. And if it was 3 times x minus 2, it would be 3x minus 6. We also learned about distributing a negative. Negative 3 times x is negative 3x. Negative 3 times a plus 2 is negative or minus 6. Remember? We don't want to see 2 symbols there. Keep it simple. And negative 3 times x minus 2 times the quantity x minus 2 will be negative 3 times x or negative 3x. And negative 3 times negative 2 will be plus 6. So the distributive property, when we learned it, it's all about multiplying an algebraic expression like the ones you see here, 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 and here, by a multiplier. Now, in this case, these are all just numbers, a constant. But when we multiply a polynomial like this, poly because it's 2 terms, remember, so binomial in fact, by a monomial, it's the same thing as the distributive property. What's the difference? Well, the difference is now I also have to think about my rules for multiplying monomials. We have rules for these. The laws of exponents. So we still have to think about our laws of exponents here because the individual things I'm multiplying are monomials. So 3x times x. X times x is x squared. So 3x times x would be 3x squared. And then 3x times a minus 2, well 3 times minus 2 would be minus 6. So 3x times minus 2 is minus 6x. Okay, so then next we move on to 5x times the quantity 3x squared minus 2x minus 1. So again, you're thinking about your monomial rules all the way through here. And notice that if it's 1 term times 3 terms, we do get 3 terms coming out. So 5x times 3x squared. 5 times 3 is 15. X times x squared. Again, as we learned, we're adding the exponents together, or I just think it out. X times x squared would be x times x times x, or x cubed. 5x times minus 2x would be minus 10, and then x times x, x squared. 5x times minus 1 is minus 5x. Now you'll notice I didn't go any further because in each of these problems, this is the simplest form. There are no more like terms. Remember, like terms are same variable with the same exponent, and I clearly don't have that here. Go ahead and do the last one on our list here for this first new concept in the video. So negative 2x squared times 3x. Negative 2 times 3 is negative 6. X squared times x is x cubed. And then negative 2x squared times positive 4x squared. So minus 2 times positive 4 is minus 8. And then x squared times x squared is x to the 4th. Now you should notice something on this last one. Uh-oh. Mayday, mayday, this right here is not in standard form. Now, does it say we have to put them in standard form? Well, I didn't give that direction. But most of the time, they want our answers in standard form. So let's go ahead and rewrite that real quick. Remember, standard form means in order of descending, not ascending degree. See, this is smaller degree, so this term should have been first. Meaning it should have been 8x to the 4th minus 6x cubed. So that's a polynomial times a monomial. So really it is just distributive property on steroids. It's distributive property, but we also have to think about our exponent rules. What happens when you multiply 2 polynomials? Well, let's think in terms of something simple to begin with. Let's say 2x plus 3 times x plus 4. Well, what do you do? What do you do? Is it just 2x times x here? And then 3 times 4? Well, it's not. And what I want you to go back and remember is I want you to remember something you did in 3rd grade called an array. If I did an array for the product 2 times 3, what I would do is make a little rectangle where it's one dimension is 2 and the other dimension is 3, and then fill in the rectangle. And what that did is that gave me the product. 2 times 3 is equal to 6. So 2 times 3 equals 6. Well, we can do the same thing with polynomials. And we learned in class that we're talking about these blocks, right? So let's look at an example, or the same example, but with the blocks. Well, if I want to fill in this array, this space in here, well, let's think about how I would fill that in. So let me make sure I have the right colors. Use the green. X times x would give me x squared. And so would this one. What would x times 3 give me? Well, it would give me 3x. So you're noticing so far that what we do is we end up multiplying all of the parts. 2x times x is multiplied. The linear terms get multiplied. And so what we end up with is a filled in rectangle. Hold on, let me go ahead and pause it. Phew, there we go. We get that whole thing filled in. So what we actually get if we go through and we label it all up is we get 2x squareds. So 2x squareds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11x. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What? A trinomial? But we multiplied 2 binomials. Well, that's great. The area model shows it perfectly well, that we're multiplying this times this, and we filled it in and got this. But how can I get this without having to draw a picture every time? Well, of course, you know Miss LeCompte better than to think I'm going to make you guess. You have 3 different methods. Let's explore them. The first method is using the distributive property, and I have 3 examples here for us to do. We're going to do 2 together, and then you're going to try 1 on your own each time. So for the distributive property, it's the same as it was before, except that instead of distributing just to one set of parentheses, you're distributing this first, the 2 terms individually to the entire set of parentheses. So let's start with x times the x plus 3. So x times x plus 3. And then you have 2 times the x plus 3. So it's 2 sets of distributive property. Let's go ahead and do that and combine some like terms. So this is x squared plus 3x plus 2x plus 6. Look at where we got them from. X times x squared. X times 3, 3x. 2 times x, 2x. And 2 times 3, 6. Combine your like terms in the center, and we have 5x there. So we end up with x squared plus 5x plus 6. Okay, let's try this next one. Same idea. I'm going to write underneath it because I kind of ran out of space. I'll switch to a different color. So it's x times x minus 4 and minus 1 times x minus 4. So it's x times x minus 4 and minus 1 times x minus 4. What does that give me? Well, x times x squared. X times minus 4, minus 4x. Minus 1 times x is minus x. And minus 1 times minus 4 is plus 4. It's like a negative times a negative. We get a positive. Now you see why I've been harping on those distributing negatives for so long. Combine your like terms in this one, and we get x squared minus 5x plus 4. So I'm going to pause it and write out the third one. And I want you to try it yourself. And then go ahead. So pause it, please, and try this third one. Same idea we had for the other 2. Distributing the first 2 terms individually to the second set of parentheses. So I'm going to pause it and do it myself, okay? And here it comes. And there you go. We end up with 2x squared minus 3x minus 5. Is that what you got? All right, so this is using the distributive property. So this is specifically using our good old friend, the distributive property. But I have 2 other methods for you. Let's try the next one, which is using a table. Okay, using a table. This is great for my visual folks. So this time we're going to take and we're going to put these 2 expressions. We're going to put them in our table, on our table. We're going to put the first one across the top. And we're going to put the second one down the side. So x and then plus 3. And I like to put the plus 3 next to the x, plus next to the 3, rather than like sitting here in between. I like to put it here because it reminds you it's a positive 3 right there. So what do we do with that? Well, we multiply, just like the array, except without the picture, we multiply these 2 and put it in this box. So x times x is x squared. 2 times x is 2x. X times a plus 3 is plus 3x. And this is positive. Let me put a plus in front of the 2x so I remember it's positive. And then 2 times 3, positive 6. And then as you had before, you still have to combine your like terms. 2x and 3x makes 5x. So x squared plus 5x plus 6. Now the table is great, but it is really just a method for you to try and get organized. It is not something I expect to see you writing indefinitely, okay? So I'm going to pause it and I'm going to write out the other two. I want you to try the same thing. You already know the answers because we did these problems with the previous examples, but I still want you to try it, please. Okay, so I'm going to pause it and do them. You do the same thing. Here they come. And there we go. So, again, same answers as before. The answers are not the issue. It's the process. So here we have x times x squared minus 1x minus 4x plus 4. Combine like terms. Negative 1 and negative 4 makes negative 5. Here we have 2x times x, 2x squared. Don't forget about the 2. See, both of these were just x times x. Don't forget 2x squared times x is 2x, or 2x times x is 2x squared. Minus 5x plus 2x minus 5. And then the like terms here, negative 5 plus 2 is negative 3. Okay, one more method, and this one is my favorite. It's called the FOIL method. And no, not this, not actually using FOIL. But F stands for the word first. O for outer. I for inner. And L for last. First, outer, inner, last. And what, pray tell, are they talking about? Well, the first is the product of the first term in each set of parentheses. So, F for first, x times x, x squared. O for outer is the product of the outer things in the parentheses. So the outside would be the x on this one and the 3 on that one. So O for outer plus 3x. Inner be the inside thing for each one. Plus 2 times x, so plus 2x. So that's inner plus 2x. And finally last, the last part of each one, plus 2 times plus 3, plus 6. And that's L for last. All right, hopefully you think that's pretty good. Why don't you try the other two using FOIL, first, outer, inner, last, and try to remind me to show you FOIL fingers when we have class next time. It's entertaining. It's from a former coworker from a long time ago. All right, I'm going to go ahead and do the other two using our good old friend FOIL. So pause it if you're going to try it yourself, but I'm going to power right through with video so you can see first, outer, inner, last, okay? So first, outer, inner, last. So first, x times x, x squared. Outer, x times minus 4, minus 4x. Inner, minus 1 times x, minus 1x. And finally last, minus 1 times minus 4 plus 4. X squared minus 5x plus 4. Again, same answer we had before, but you see the math written out, okay? First, outer, inner, last. So first, 2x times x, 2x squared. Outer, 2x times plus 1, plus 2x. Inner, minus 5 times x, minus 5x. And finally, last, minus 5 times plus 1, which is minus 5. Like terms, 2x squared minus 3x for the plus 2 minus 5, and then minus 5 at the end. And you'll notice that when you multiply two linear binomials, linear binomial, linear binomial, all of these were linear binomials, you get a quadratic trinomial. That is significant. All right. The last thing we're going to do in this video is look for patterns. So I'm going to go through and multiply this all the way out and show you what we get, and I want you to start looking for patterns. So if you want to pause it and do it and then watch, that's fine, but I'm going to go ahead and multiply it out. I'm going to shut my mouth, and I'm going to multiply them all the way out. You could just listen to this nice background. I don't even know what this is, but it's nice. It's making me tired. I promise to stay awake. Okay, so look over that. You clearly see the pattern here. Same numbers, switching the signs around as we went. You should also notice a pattern here and in here. So, examine and jot down any patterns that you might notice, and we will talk about them in class next time I see you. Thanks, guys. See you in class.